And in this homework, we need to implement a knife-based recommender and use another collaborative filtering recommender to construct a hybrid recommender. So in a knife-based recommender, we basically need to calculate this constant k value, which is 1 divided by overall 1 divided by the probability of like times the probability of feature given like, plus the probability of dislike times the probability of feature given dislike. So in order to do that, we need to basically initiate 4 placeholders for the probability of feature given like, probability of feature given dislike, and probability of like and dislike. So in our setup model is actually setup function is actually given by the professor, which will convert the input files into 2 matrices. One is the train matrix, which contains user, item, and rating information, and the second matrix, the M feature matrix, contains each row represents an item and each column represents an associated feature. So first of all, we need to initiate 2 objects that are used to store the probability of feature given like and dislike, and 2 numbers that stores probability of like and dislike. And then we need to initiate 4 temporary placeholders and counters to basically count the probability of feature given like and dislike, and count the number of like and dislike. So in the algorithm, we're saying that for each user, we want to reset the placeholder and counter, and then for each item that the user rated, we want to get the ratings of each item. If the rating is greater than the threshold, we want to say that the user liked that item. Otherwise, if the rating is greater than 0, meaning that if there's no error in our data, the user will dislikes that item. And for each feature associated with that item, if the user liked the item, we want to say the feature given the user liked is going to increment by 1. Otherwise, the feature given user dislikes is going to increment by 1 for that specific feature. So after going through every item and every feature, we want to use the Laplace smoothing before calculating the probabilities, just to avoid dislike or like to be 0. So in order to do that, we basically add 1 to the numerator and denominator. Then we can calculate like over the probability of like and probability of dislike, and the probability of feature given like and probability of feature given dislike, and store them into the dense matrices and integer arrays that we initiated earlier. In the predict function, we basically need to initiate 2 variables that will keep calculating the probability of like times probability of feature given like, and we want to go through all the features that is associated with the item given, and then calculate the probability of like times probability of feature given dislike, given like. And with those information, we will be able to calculate the constant k, and with the constant k, we will be able to calculate the probability of like given feature and probability of dislike given feature. Then we can use the decision rule that we discussed in class and to calculate the final probability that the user will like the item. With the probability, we can convert that back with the logit. With that logit, we can convert it to probability, and with the probability, we can calculate a predicted rating for our recommendation. And in the hybrid recommender, I used the biased matrix factorization, which is a built-in method in LibRack. And the only thing I changed is I changed the setup, train model, and predict function into public class instead of private, so you can call them in private recommender. So in the private hybrid recommender, we basically initiate each recommender individually, and then we read in the configuration files that is used to do the weighted average at the end. And we're gonna set up each recommender individually and train model individually and do a prediction individually. Then at the end, we're gonna do a prediction. So here's an example of our hybrid recommender working. So this is the gradient descent algorithm. So we see that the DCGE evaluated score is 0.002, and we can actually see the actual prediction under this hybrid file.